All right, so this problem is called Addicted to Smoking. Let's read the problem first. It says 189 of 262 smokers in a survey considered themselves addicted to cigarettes. Okay. And then it says find a 90% confidence interval for the proportion of all smokers who considered themselves addicted to cigarettes. All right, so what kind of problem is this?
This is a confidence interval.
Yeah, if it says confidence interval, you know right away it's going to be confidence interval. And now, what kind of things go into a confidence interval? What are we going to have to compute here?
The p hat.
Yeah, p-hat. Okay, so we're worried about the p-hat, and the p-hat is called what?
The sample.
Yeah, this
Sample size.
No, it's not the sample size. It's called the sample what?
Portion.
Yeah, sample proportion,
okay.
right? So this is the sample proportion.
Right.
And that's going to come from these numbers up here, right? In this case, our sample size is what?
Our sample size is 262.
That's right. So the sample size is the 262. Right. And in order to find our p-hat that we're going to use for the confidence interval, we're going to use that sample size and also that other number there, the 189. But the sample size goes where?
On the bottom.
Yeah, for 262. And then to get this sample proportion, the number that goes on the top would be
189.
Yeah, 189. Okay, so let's calculate p-hat here. 189 divided by 262. Tell me what that is.
0.7213.
7213. Okay, so about 72% of smokers consider themselves addicted to cigarettes. Okay, now what we want to do is make an estimate of the population proportion from this p-hat. So the p-hat is 72%, and now what I'm interested in is how close this is to the actual overall population for all smokers. So this only tells us about, our 262 smokers, but I'd like to infer from this how big the population proportion is. And of course, in this case, I don't have access to that, but that would be called theta, right? Theta is what we don't know here, but this is the proportion of all smokers.
Right.
To consider themselves addicted to cigarettes. Okay, so this is the thing that's unknown. We don't have this, we don't know it, and the population is too big to even figure it out directly from the population. But hopefully this estimate over here is pretty close to the population proportion. Now we can see how close it is by computing an error estimate that goes with this confidence level. Now how do we do that? So I need to compute the error estimate, and the error estimate is called E, and we're going to get something like p-hat plus E is the upper limit, and then p-hat minus E will be the lower limit for our confidence interval. Now what is this thing E? So E is called the margin of error, and how do we compute E? Any idea?
Yeah, we find the formula.
Yeah, there's this formula, and the formula goes like what?
Z star.
Okay, so there's this funny thing Z star, which we'll talk about in a minute, comes from the confidence level, but then there's also something that looks like a standard deviation too.
So the square root.
Okay.
And p-hat.
On the inside, p-hat.
And then parentheses 1 minus p-hat.
Right.
Close parentheses, and on the bottom would be n.
Right. And the n is our sample size, right? That's this guy right here. Let's see about the other stuff in this formula. The p-hat here is what? That's our sample proportion, which in this case is what?
72%.
Yeah, about 72%. How do I get this Z star right here?
You have to calculate the formula first in order to get the Z star.
Yeah, let's remember what this means. What it means is, let's draw a picture of it over here. Okay, so what it means is I look at the normal curve, and then if I'm computing a 90% confidence interval, then what I'd have is inside here in the middle, I have an area that represents 90% of the area, right?
Right.
Right. And so I'm interested in the cutoffs right here that would give me 90% here and here. Now that means if there's 90% in the middle, then what percent over here in this tail on the right?
10%.
No, I gotta have it split up. 5% over here, right? And 5% over here as well. That's right. Okay.
You again?
Now,
jeez. I thought it was an online course.
And so if we want to look up the area that goes from, that has 90% in the middle and 5% on the right and 5% on the left, then I need to come up with this z value right here on the right-hand side. See that one?
Right.
Okay, so that means I got to have what percent of the area is going to be from the left side of the curve all the way up to this z value right here that I've marked with a question mark.
Well, 95%.
95%.
Right.
Now let's see if we can actually compute it. We could look it up in a table in the book,
Right.
but let's actually compute it from the normal table.
Okay.
So if I have 95% of the area from the left-hand side all the way up to this right-hand endpoint, let's look in the middle of the table and find 95%, and then we'll work backwards and find the z-score that goes with that.
Okay.
So I'm looking for 95%, so what number am I looking for?
For 0.95.
Yeah, so 0.9500. So find the
Okay.
closest thing to 0.500.
Okay. Okay, it would be 0.9505.
Okay, so it's equal. How about 0.94595? How about that one?
Yeah, that's close.
Well, actually, they're both equally close,
Well,
right?
yeah.
So let's take this second one over here. Let's take the
higher
higher one, yeah.
Okay,
Okay, so give me the z value that goes with that one.
that would be 1.65.
6.5. Okay, great. Okay, so that's what we need. That's what this z star is over here. So this time we just looked up the z star by actually computing it ourselves. But you can also get it from the book as well, too, for standard confidence interval levels. So here this is 1.65, so that's going to be the z star over here. Okay, so I think we have everything to do our e now. All right, so go ahead. The e is going to be this the z star is going to be the 1.65. Give me the rest of this stuff right here.
Okay, and the p hat is going to be 0.7213.
All right, good.
And then you're going to have 1 minus 0.7213.
Yep,
And then on the bottom is the sample size, which is going to be 262.
good. All right. Are we ready with the calculator?
Okay, so we're going to have,
So let's start on the inside. Let's do the 0.7213. Oh, wait. Let's do the 1 minus first. Okay,
Okay.
so 1 minus 0.7213.
okay, that's 0.2787.
Okay, so I got 0.7. I'm just going to copy over again. 0.27213 times, what is it?
It's 0.2787.
And so, okay. Good. All right, and on the bottom, the 262.
Okay.
Okay, so now take that number that you've got there and multiply it by the 0.7213. Tell me what that is.
And that is 0.2010.
Okay, and that goes on the top, right?
Right.
Okay, so next, while we still got that there, divide by 262. Tell me what you get.
And that's 0.00076.
Okay, good. So now, while we've got that, so that's everything on the inside now. Now let's take a square root of that.
Okay. Okay, then you get 0.02769.
2769. Okay, good. And now multiply that, while you still got it there, by that 1.65. What do you get?
And you get 0.04570.
So, okay, good. All right, now, so this is our e, and this is the margin of error, right?
Right.
So now we're going to take p hat and add it to the e, and p hat and subtract the e from it as well, too.
Right.
Now, so this as a percent represents about what?
Around 5%.
It's around 5%, right?
Mhm.
So our proportion, the sample proportion was about 72%, then plus or minus about 5% for the error estimate, right? Okay, so let's actually do it. Let's do p hat plus e. Okay, so the e is, or the p hat is 0.7213 plus the 0.057. 0.0457, sorry.
Okay. It's 0.767.
Yeah, okay, and that's what we said. We said it was about 72% plus 4%, right?
Right.
And let's do the p hat minus e as well, too. So it's going to be 0.7213
Right.
minus 0.0457. What do you got?
That's 0.6756.
Okay, 676, right? So we're gonna-
Right.
Okay, so
yeah.
that's good. So that gives us our interval. Our interval looks like this. Whoops. It looks like in the middle I got 7.72. That's this guy right here. And then when I add e to that, it's at about 0.77, right?
Right.
So this is the p hat, and this is the p hat plus e.
Right.
Okay, and then over here on the left, I have the p hat minus e, and the p hat minus e, let's round it off to 2 digits, it's about 6.68, right?
Right.
0.68 right here. And this is p hat minus e. So that gives us our confidence interval. So now the way things work here is because this is a 90% confidence interval, we say we're about 90% confident that the population proportion is going to be trapped between 0.68 or 68% and 77%.
Right.
Got it?
Got it.